Hello, mathematicians. I wanted to go through the first one of this matching worksheet with you, kind of give you little tricks and pointers. So without further ado, let's get into this. Before we start, when we're talking cotangent versus tangent, hopefully we remember some of this, but let's just give ourselves a few little notes here. Tangent in general is going to have asymptotes at pi over 2 and negative pi over 2, and is going to go from left to right, from the bottom, negative infinity to infinity. And it's just going to keep repeating that over and over. In general, that's tangent. Cotangent, on the other hand, so I'll put a tangent here. Cotangent is going to have asymptotes at 0 and pi, and negative pi if we need to do that. And that one's actually going to go from positive infinity to negative infinity. Okay, so just in general, as long as there's no negative signs, or remember, negative signs flip them upside down, but in general, these are the things we're looking for. How about secant and cosecant? Okay, to graph secant, we need to graph cosine, and cosine starts at a maximum on its way down. So cosine would look like this. Let me switch colors here on you. Then secant gets asymptotes at all these nodes. And then we have our reciprocal behavior stuff. Maxes are mins, mins are maxes. So something we can notice here, a typical secant function is going to be centered on the y-axis. It's symmetrical about the y-axis. That's called an even function, by the way. Cosine and secant we call even functions, because if I flip everything from one side of the y-axis to the other, it would all line up on itself. So just in general, as we're going through and looking at these matchings, if we see that it's centered up on the y-axis, we should already be thinking secant. Okay? And then that leads us to our last one. Cosecant is not. Cosecant is not an even function. So it will not be symmetric, but cosecant comes from sine. Sine looks like that. Asymptote still at the nodes. And then our reciprocal function. So as we're going through and looking at these, we can kind of take these little hints with us about where is it centered, what does it look like, and that'll kind of point us in the right direction. So here's the worksheet that you guys have been assigned. It's small. Hopefully you guys can see it okay. I'm trying this out just to see how it works. So we have our little bank of equations. We're going to click, copy, or cut and copy and move over whatever equation is supposed to go with this one. So as I look at it right now, is it centered on the y-axis? Well, first of all, it's the crazy circus looking thing. We got our parabolas. So we're thinking secant or cosecant. So right off the bat, any of these tangent ones, it's not going to be that. It's got to be secant or cosecant. And the question is it secant or cosecant? Well, if it's not centered on the y-axis, if it's not an even function, I can't flip it all over. If I flip this to the other side, there's nothing for it to land on. It's not symmetric about the y-axis. It's cosecant. So that leaves us with a couple of options here. It could either be this one, because that's a cosecant, or it could be this one. That's a cosecant. Do we see any other cosecants? No. Okay. If this was a negative, or because this is a negative, that means that cosecant should be on its way down, or sine would be on its way down. I don't want to use that. I want another piece of scratch paper. Remember, if sine was negative out in front of it, it would actually start from 0 on its way down. This would be negative sine. Okay, so then negative cosecant would have its first little parabola be a down opening parabola. And then that is not what we have. Our first one is not a down opening parabola. Our first one is a top opening parabola. So it has not been flipped upside down. That leads us to this one. 3 cosecant of x over 2. And the 3 kind of gives us that idea of where those values are. They're not 1 anymore, they're 3. And that's where this one is. That helps me. 0, 2, 4. So that is 3. That looks good. So we're just going to cut this equation and paste it right down here. Y equals 3 cosecant of x over 2. And now the last piece of this is to find these asymptotes. So where is this asymptote? That one looks pretty easy to me. Hopefully you got that one too. That's at 0. So that's the vertical line x equals 0. And if we plugged a 0 in here, 0 divided by 2 is 0. The cosecant of 0, well, that's like 1 over the y-coordinate. Well, the y-coordinate is 0 if I'm at 0. So it blows up. That's why it's an asymptote. The next one then, when does cosecant blow up again as we go around the circle? Okay. I can also kind of cheat and see that this is just a little bit beyond 6. Okay, a little bit beyond 6, 6.28. It's actually 2 pi. Okay, if I plug a 2 pi in here, 2 pi over 2, I would just be left with pi. Think about our unit circle. There's pi. That's the point -1 comma 0. And again, if I tried to take the cosecant right here, 1 over the y coordinate, it would blow up. No good. Okay. In a pinch, if you have to, you could just sketch little graphs of these things. Like I could just exchange this for sine, 3 sine of x over 2, and then figure out where those nodes are. Remember, because nodes become asymptotes. So if we have to do that, we have that method. We can do that. But this is actually going to be, we decided, 2 pi. And then I just like patterns, right? 0, 2 pi, keep that pattern up, 4 pi. There's our first one. You won't have any work because you're trying to do this on a computer, hopefully. We'll see how it goes. If it doesn't work out, yes, you can print it and make a copy, or print it and turn it into me. But let's try to do this all on Google Classroom. I'll grade it on Google Classroom, and I'll send it back to you. All right, moving on.